So this is what I've actually just deduced from the abstract, just my notes while I was literally just reading this abstract here and trying to figure it out, because the abstract basically summarizes an awful lot of what you need to know. It basically tells you an overview of what they did and what they found. So always go for the abstract first. Essentially what I found here when I went down to the bottom, by the time you get down to the bottom, you see some of the big points here. They didn't find that putting GA3 or that the hormone, there wasn't any relationship between that and what they said was stress tolerance. No direct relationship between helping improve like temperature tolerance. But they also, when you read through this, instead of just spraying the gibberellic acid on, they also sprayed on a different hormone as well. So they had two hormones that they were testing. And so you have to try and, in this case, split up what was caused by the GA3 and what was caused by this other hormone. They essentially said that the other hormone, this PBZ, increased, helped with temperature tolerance, but the GA3 helped with, where would I put it here? GA3 did not improve temperature tolerance, but it did improve the weight of both the groups, and it also was linked to more gene expression of a specific gene, this cell expansion. So that means it's making a protein. So the more GA3 you sprayed on it, the more of this gene was expressed, and therefore it was making more of the protein linked to that gene. So, and had better weight. And that was in both test groups, because if you read through, and I actually did do a quick screencast of my process going through this and taking notes, no sound, just to show you one way of doing it. But when you go through it, basically I found that they had two different test groups. Okay, they tested temperature tolerant strains. That's the short form of their genotypes, because they're different genetic strains of wheat. These two genotypes here were temperature tolerant, and these two temperature genotypes here were temperature susceptible, which means they don't do well in certain temperatures, whereas these guys tend to be able to grow in a greater range of temperature conditions. So they tested 1, 2, 3, 4 strains of wheat, 2 temperature tolerant, 2 temperature susceptible. They sprayed both gibberellic acid and this biosynthesis inhibitor PBZ on them all, on the test groups, and compared to see which ones grew best. So we have to account for that when we're reading the tables and graphs. We're going to have to try and focus in on the results that show the gibberellic acid effects and not the PBZ effects. But essentially, they have summed up and told me that if you look at their results, they'll find that, well, if you look through the results really quickly, they say, yes, we did have a higher growth and yield rate. But then when you read a little bit further, they say it was found in the temperature tolerant genotypes, but they're pretty sure it was only because of this other hormone, PBZ, not the GA3, that was the reason for the high growth and yield rate. So it wasn't the GA3 that gave them more growth and yield, it was the PBZ. So I'll have to make sure I look at that when I now go and look at the pictures that are in this article.